Let's take a look at question 22 from chapter 19. So the question says, managers of 1,200 different retail outlets make twice a month restocking orders from a central warehouse. Past experience shows that 4% of the orders result in one or more errors, such as the wrong item being shipped, the wrong quantity being shipped, or the item being requested but was never shipped. So random samples of 200 orders are selected monthly and checked for accuracy. So we have a couple parts to this problem. First, we need to construct a control chart, and then, given 6 months of data, plot the data on the control chart, and then what does your plot indicate about the order process? So let's first construct an NP chart. So we know our P is 0.04 and our N is 200. And we have this formula for our upper control limit and our lower control limit for an NP chart. So if we plug in what we know with our N and our P, it will simplify down into 8 plus and minus 3 times the square root of 7.68, or 8 plus and minus 8.314. So your upper control limit is those two numbers added together, which will give you 16.314, and your lower control limit will end up as negative 3 or negative 0.314. We'll just use 0. Now we need to plot on our NP chart. So our 6 months of data show the following number of orders with one or more errors. We had 10, 15, 6, 13, 8, and 17. We're going to plot that over on our NP chart. So 10, 15, 6, 13, 8, and 17. So you'll notice the first 5 pieces of data are within our limits. So we're fine there. But that 6th piece of data, that 17 that we plotted, that was above our upper control limit. And so since at least one piece of data is outside of our limits, the entire process is out of control. So now we construct a P chart for this situation. So our P is still 0.04 and our N is still 200. Our formula looks a little different compared to our NP chart. So it's P plus and minus 3 times the square root of P times 1 minus P all over N. We plug in the numbers that we know. It simplifies down into 0.04 plus and minus 0.0417. So your upper control limit, that's going to be those two numbers added together, giving you an upper control limit of 0.0817. And your lower control limit are those two numbers subtracted, so negative 0.0017, but we will just use a lower control limit of 0. Now, the data that we were given were the number of orders with errors. So this is where we now need to change those into proportions if we want to use a P chart. So we have to take the 10, the 15, the 6, and turn them into proportions. To do that, we divide them by our N. So our proportions, the 0.05, the 0.075, and the 0.03, those are going to be the numbers that we are plotting on our P chart. So if you are given data like 0.05 and 0.075, a bunch of proportions, a P chart will work better for you. If you are given data like 10, 15, 6, and 13, then an NP chart will save you this extra step. But we found our proportions, so let's plot them on this P chart. So we have 0.05, 0.075, 0.03, 0.065, 0.04, and 0.085. So just like when we plotted on the NP chart, the first 5 pieces of data, nothing wrong with them. They're within the limits. But since our 6th piece of data is above our upper control limit, the entire process is out of control. So when you're working through a problem like this, you can choose either to make a P chart or an NP chart, and your conclusion will end up the same.